Hi Year 12, today we're looking at mean and variances of a binomial distribution. So the shape of a binomial distribution is when p is less than 0.5, the distribution is positively skewed. When p equals 0.5, the distribution is normal or symmetrical. And when p is greater than 0.5, the distribution is negatively skewed. For the mean of a Bernoulli distribution is p. The binomial distribution is n Bernoulli trials. So the mean or expected value of a binomial distribution is EX equals NP. Now this is on your reference sheet, so you do not need to remember this reference sheet. So then the variance of a binomial distribution is Varx equals NP of 1 minus P. So it's the same formula for a Bernoulli distribution. However, we just multiply it by n. And again, this is on your reference sheet. So our example is to draw a histogram for each binomial distribution and describe its shape of the graph. So we have a probability with success p equals 0.2 and a number of Bernoulli trials is 8. So what we need to do for this is we need to do the probability that x equals 0 all the way up to 8. So this one is 8 choose 0 of our probability of success is 0.2 to the power of 0, and then the probability of failure will be 0.8 to the power of 8. And on our calculator, this gives us 0.1677, and we're going to round it to 3 decimal places, so it's 0.16. Now the probability that x equals 1 is 8 choose 1, 0.2 to the power of 1, 0.8 to the power of 7, and this to 3 decimal places is 0.336. The probability that x equals 2 equals 8 choose 2, 0.2 to the power of 2, 0.8 to the power of 6, and this to 3 decimal places is 0.297. Now we have the probability that x equals 3, so that's 8 choose 3, which is 0.2 to the power of 3, 0.8 to the power of 5, and to 3 decimal places this is 0.147. The probability that x equals 4 equals 8 choose 4, 0.2 to the power of 4, 0.8 to the power of 4, and this equals 0.046. We then do the probability that x equals 5, so this is equal to 8 choose 5, which is 0.2 to the power of 5, 0.8 to the power of 3, and to 3 decimal places this is 0.009. The probability that x equals 6 equals 8 choose 6, 0.2 to the power of 6, 0.8 to the power of 2, and to 3 decimal places this is 0.001. And then we have the probability that x equals 7 equals 8 choose 7, 0.2 to the power of 7, 0.8 to the power of 1, and this equals to 3 decimal places 0.000, and the probability that x equals 8 is 8 choose 8, 0.2 to the power of 8, 0.8 to the power of 0, and this equals 0.000 to 3 decimal places. So now we want to draw this as a histogram. Yes, it asked us to do it as a histogram. So we have our graph laid out. So when we sub in 1, we get 0.168. So 168 is roughly here. Now we have probability of 1 is 0.336. So that's closer to here. Probability of 2 was 0.297. Probability of 3 was 0.147. Good job. Probability of 4 was 0.046. Probability of 5 was 0.09. Probability of 6 was 0.01. And the probability of 7 and 8 were 0. So we now want to say whether we want to describe its shape. So as the probability equals 0.2 is less than 0.5, or as p equals 0.2 is less than 0.5, that's our success. We have that the distribution is positively skewed. So then example 2, we have find the mean and variance of each binomial distribution. So the first one is a tail is tossed 100 times and the number of tails is recorded. So the probability of getting a tail equals the probability of x equals 1. The probability of 1, which is success, is equal to a half. So therefore p equals a half. So we'll have n equals 100. So mean, which is equal to our ex, is equal to np, which equals 100 times a half, which equals 50. Our variance, which equals var x, is np lots of 1 minus p. So this is 100 times a half, bracket 1 minus a half. So this is 50 lots of a half, which equals 25. We then have a pair of dice is rolled 120 times, and the sum of 8 is recorded as a success. So what we need to do is we need to work out the probability of the sum of 8. And so how we're going to do that is by drawing up a quick table. Oh, that was a nice parabola, but that's not what we want. That will do. So our table is going to have 7 columns. I'm sure there's a function that just... That's 7. And 1, 2, 3, 4. And 7 rows. 2, 3, 4, 5, 6, 7. So now we want to put our numbers in here. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. And so the squares where we would get a sum of 8 when we roll 2 dice together would be, we wouldn't get 1 plus anything, but we'd get 2 plus 6. We'd get 3 plus 5, 4 plus 4, 3 plus 5, and 6 plus 2. So the probability of a sum of 8 equals 5 over 36. So it goes 5 times over a total of 36. So therefore p equals 5 over 36. And then n is how many times we rolled the dice, which was 120. So our mean, which equals our ex, is equal to np, which equals 120 times 5 over 36. When we put this into a calculator, we get 16 2/3. Our variance, which equals var x, equals np 1 minus p, which equals our 120 times our 5 over 36, bracket 1 minus our 5 over 36, which is 14 and 19 over 54.